All right, we're going to look at parametric equations. Yeah, so this is a review for parametric equations. It's going to be so fun. Let's do these two. I'm going to skip around because some require more effort than others. So where is my cursor at? Right here, I guess. So we're doing two problems here. Maybe we'll just do these two problems for the video. So number 82. So we need to find a horizontal tangent line and a vertical tangent line. Vertical tangent lines exist when the slope is infinity, and horizontal tangent lines exist when their slope is 0. And this is important because we're going to find the derivative of these equations and compare them to each other. This way we can set the top equal to 0 to get horizontal tangent lines and the bottom equal to 0 to get vertical tangent lines. So let's take the derivative. It's going to be derivative of y is 1 minus 1 over t squared. Derivative of x is 1 plus 1 over t squared. Let's simplify the numerator and denominator. We're going to get t squared minus 1 over t squared and t squared plus 1 over t squared. These cancel out and we're left with t squared minus 1 over t squared plus 1. So I can tell just by looking at it that there are going to be no vertical tangent lines because this cannot equal 0 unless you use like t equals I or something. But this one can. If we set that equal to 0, we can have t equal -1 or 1. So there are no vertical tangent lines and there are 2 horizontal tangent lines. Let's plug our t values back into the original equations to find what those x and y coordinates are. So at t equals -1, we'll have -1 minus -1. So -1 plus 1 is 0. Then we'll have negative t, -1 plus -1, so that's -2. And then at t equals 1, we're going to have 1 minus 1, which is 0, and 1 plus 1, which is 2. So for this parametric curve, there are 2 horizontal tangent lines at points 0, -2, and 0, 2, and there are no vertical tangent lines. Easy peasy. Lemon squeeze. Let's look at the second equation, the second question, because it's a little different. So we need to find the equation of the line tangent to the graph. X equals t cosine t, y equals t sine t, at t equals pi. So let's plug in pi into these to get our x and y coordinate at t equals pi. If we plug pi into this x equation, we're going to get pi times cosine of pi. Cosine of pi is equal to -1, so our x value is just -pi. T is pi, sine at pi is 0, so our y value is 0. So we have a point. Sounds like the perfect time to use point slope form, right? Does my cursor keep getting away from me? So this is point slope form. If we plug in our values, we have y minus 0 equals some slope x minus -pi, which is plus pi. So now we just need to find the slope at t equals pi. Well, hey, we just did finding slope for this one, so why don't we do dy over dx? So what is the derivative of y? Well, this is going to be a product rule, so let's take the derivative of y by firstly taking the derivative of sine and multiplying it by this one, so that's t cosine. Then we're going to add the derivative of the first term times the second term, so that's just sine. There's a t there. Let's do the same exact thing for finding the derivative of x. We're going to get negative t sine t plus cosine t. Let's plug in pi. Yeah, sounds like a good time. So we know that the top is going to be what? Negative pi plus 0 over 0 plus negative 1. So this is equal to negative pi over negative 1, which is equal to pi, positive pi. So our slope at t equals pi is pi, which means that the equation for our graph, for our line, is equal to y equals pi times x plus pi, or y equals pi x plus pi squared. Thank you so much. This has been riveting for me, quite the journey. I'm glad that I could have you with me. Goodbye.